Hello friends, welcome to my channel Math Realization. On this episode we are discussing on numbers divisible by 2, 3 and 5, and another topic is prime factorization. So we are discussing on two topics. So why 2, 3 and 5 only? Why we are seeing only the first three prime numbers, the numbers that is only divisible by 2, 3 and 5, because there are some rules by which the numbers are divisible by 2, 3 and 5, but other prime numbers like 7, 11, 13, there is no such specific rule. You have to check it by check it by yourself, like by just division or multiplication, either they are divisible by or not. So there is no specific rule for other prime numbers, but for these numbers there is some specific rule. So we are discussing the numbers that is divisible by 2, 3 and 5. So let's start. First number divisible by 2. Yeah, this is simple one. Number divisible by 2. So if a number have last digit or unit place digit as even or 0. So 0 is also even number, don't be confused. 0 is an even number, okay? Even number or 0, then the number is divisible by 2. Let's just see an example. So a number that have last digit or unit place digit, for example 20. See, this is the last digit or unit place, or we call it ones place value, tens, and if there is another number 100th value, 100 place value, like that. So this is the ones place digit, so it is 0 as per our definition, even or 0. If the number, this is a given number, if it have last digit or unit place digit as 0 or even number, then that is divisible by 2. Let's check it. 2 times 1 is 2, and subtraction, it comes here, is not it? And if you write this 0 here, then you have to add a 0 here, because 2 times 10 is 20, not 2 times 1 is only 2, so you have to write this 0 here, okay? So it is exactly divisible, there is no remainder or 0 remainder, so 20 is exactly divisible, and we have seen the last digit is 0, so it is divisible. Let's take another example. 102. Okay, so let's divide it, either it is divisible or not. So as per our definition, last digit is even number, so it must be divisible. So let's check. So there are some rules for division. If this number or this first digit, while we are dividing by 2, if this digit is smaller than 2, so we have to take two numbers, okay? So we can take two numbers at first, but not on the second step. At first we can take two digits if the first digit is less than the divisor. So this is divisor, dividend, here we write quotient, and this is the remainder, okay? At last, that is the remainder. So let's divide it. 2 times 5 is 10. So minus, after subtraction, it's become 0, and we have to write here 2. 2 times 1 is 2, so the remainder is 0, or you can just cross it. So this is also exactly divisible. So let's see another example like let's say okay 306. Yeah, well, let's see the an example that is not divisible by 2. Let's take an example like this. Okay, 313. So let's see, let's check it, either it is divisible by 2 or not. As per our definition, the last digit, this ones place digit, is odd number, so it must not be divisible. It is not divisible as per our definition. Let's check it. 313. So 2 times 1 is 2, because this is greater, this digit is greater than the divisor, so we can take only one digit here. So 1 after subtraction 1, and we have to write here this 1. So 2 times 5 is 10, again subtraction 1, and we have to write it here 3. 2 times 6 is 12, after subtraction there is only 1, so this is the remainder, and the remainder is already smaller than 2, so we cannot divide 1. Hence this number is not divisible by 2 because it has the last digit as odd number. Okay, I hope you understand this. Now we will move on. Number divisible by 3. Numbers divisible by 3. Okay, so our next one is numbers or number divisible by 3. To see either a number is divisible by 3 or not, let's write its definition first. If the sum of the digits of a given number is divisible by 3, then the given number is also divisible by 3. So what does this definition means? If the sum, not the number. Okay, let's check by example. So sum of the digits means, let's see an example. Like you can take any example. Let's take 18 first. Okay, from simple we will start. Let's take 18, and sum of the digit, these are the digits, this ones place digit, tens place digit. So as per question, as per definition, sum of the digit means you have to add the digits, that is the digits are 1 and 8, so you have to add it, and their sum is how much? 9. So you have to check this sum, either this sum is divisible by 3 or not. So while 9 is divisible by, either 9 is divisible by 3 or not, divisible means that the remainder must be 0. Okay, don't be confused. Divisible means the remainder must be 0. So 3 times 3 is 9, remainder is 0. So if this sum is exactly divisible by 3, then this number is also divisible by 3. Let's see 18 is divisible by 3 or not. Yeah, because as per our definition, its sum is divisible. The sum of the digits of given number is 18, divisible by 3, then the given number is also divisible by 3. So 18 must be divisible by 3. Let's check. 3 times 6 is 18. So yes, 18 is divisible by 3. Let's take another example like 834. Okay, so because its last number is even, we don't have any rule for even or odd for this 3. We have to see the sum of the digits. So let's add all the digits. 8 plus 3 plus 4, ones place digit, tens place digit, hundredth place digit. So their sum is 15. Yeah, 15. So this sum must be divisible by 3. Yes, let's divide it. 3 times 5 is 15. Yes, this sum is divisible by 3, hence the number is also divisible by 3. Check it. 834 must be divisible by 3 because its sum is divisible by 3. So 8 times 2 is 6, subtraction 23, 3 times 7 is 21, remainder after subtraction 2, and this 4 comes here. 3 times 8 is 24. So there is no remainder, means this number is divisible by 3. So to check it, either it is divisible by 3 or not, you don't have to divide it by 3, just check their sum is divisible by 3 or not. Okay, so now we will see either a number is divisible by 5, how a number is, or which number is divisible by 5. So for next numbers divisible by 5. Okay, so if a number have last digit 0 or 5, or last digit or unit place digit, 5, then the number is divisible by 5. Understood? Let's check it, either a number is divisible by, how a number is divisible by 5. Let's take 15. Let's start from smaller number. So this is the unit place digit or last digit, so it is 0 or 5. Yes, it is 5, so it must be divisible by 5. 5 times 3 is 15. Yes, there is no remainder, so 15 is divisible by 5. Let's take another example like 120, because this is a greater number. So let's check it. It's as per definition, last digit is, this is last digit, it is 0, so it must be divisible by 5. Let's check it. 5 times 2 10, 5 times 4 20. Yeah, it is also divisible by 5. So as per there are only 3 rules for 2, 3 and 5, and there is no specific rule for other prime numbers like 7, or you can say 11, 13. There is no specific rule. You have to check them by division or multiplication. There is no specific rule for them. So now after this we will move on prime factorization. Our next topic is prime factorization. Yes, prime factorization. So for prime factorization means, let's see what does it mean. Prime factorization. So in prime factorization, prime numbers we have already discussed in our previous video, in prime and composite number video, so you can check from there. And factors we have clearly discussed there. What do we mean by factors? So prime factorization means factors that are only prime. So we are not taking any other factors, we are just seeing only prime factors. So how to find the factors? Let's see. Let's see from an example 30. So what are the prime factors? Let's find its prime factor by prime factorization. So we can do prime factorization as, so we will use the 3 rules that we have just seen. Either it is divisible by 2 or 3 or 5. Let's see. So let's start with the smallest number 2. Either it is divisible by 2. Yes, because its last digit is 0, so it is divisible by 2. So let's divide it. 2 times 1. 2 times 1 is 2, but here is 3, So 3 minus 2 is 1, and this 1 comes in front of this 0. Okay, don't be confused. 2 times 1 is 2, here is 3. So if 2, we can write here 2, then 3 minus 2 is 1, and that 1 comes in front of this 0, it becomes 10. If you write here 1, it becomes 10. So 2 times 5 is 10. 2 times 5, 10. Okay, again let's check. 5 plus 1 is 6, so it is divisible by 3. So let's divide it by 3. 3 times how much is 15? 3 times 5 is 15. Okay, again 5 times 1 is 5. So we will divide up to that time when there must be 1. Okay, so we will write the factors or prime factors of 30 as 2 times 3 times 5, or either you can write times 1, because something times 1 is always that something. So this is a times 1 is a, 2 times 1 is 2, yes, minus 7 times 1 is minus 7. So we know we don't need to write 1 here. Okay, or you can say we are writing only the prime factors. So 1 is not a prime number, like that you can also say that. And I have seen that some of the students always write it in increasing order, like first you will check by 2, then you will check by either it is divisible by 3 or not, and either you then after that if they are not divisible by 2 or 3, then you can check by 5. But it does not matter in which order you are solving it. Suppose let's see the same example. Suppose I will first divide it with 5. Okay, so 2 times how much, sorry, 5 times how much is 30? 5 times 6 is 30. So I can take it in any order. I can divide it by 2 because it is divisible by 2. 2 times 3 is 6. 2 times 3 is 6. So again this 3 must be because it is a prime number, so the prime number is divisible by the itself or 1. So we don't need here 1, we will divide it by 3. Okay, like this. So again you will get 5 times 2 times 3, same answer. Yeah, 5 times 3 times 2 or 5 times 2 times 3, same thing, you will get the answer 30. So these are the prime factor of 30. Okay, let's take another example. 102. Okay, we have already seen how to divide the number like this. So let's find its prime factors of 102. You can get the prime factors of 102. Let's start with 2. So either it is divisible by 2 or not. To see it is divisible by 2 or not, you have to check its last digit. So its last digit is 2, even number, so we can divide it by 2. Here the first digit of the given number, this is the given number, its first digit is 1, which is less than 2. So we need to take 2 digits, that is 10. So divide it. 2 times 5 is 10. There is no remaining, so nothing comes in front of this 2, so it is 2 only. So 2 times 1 is 2. Okay, now this is divisible by which prime number? Let's check it. Okay, it's sure it is not divisible by 2 because the last digit is odd. Okay, check it by 3. How you will check? 5 plus 1 is 6, so 6 is divisible by 3, so we will divide it by 3. So now 3 times 1 is 3. What's the remaining? 5 minus 3 is 2, so 2 comes in front of 1, means if you can write 2 here, then it becomes 21. So 3 times 7 is 21. Okay, but here you can check it, it is divisible by which prime number. So let's see, it is not divisible by 2 because here is odd number. It is not divisible by 3 because 7 plus 1 is 8. So it is not divisible by 3 also. It is not divisible by 5. So this 17 is also a prime number. So if you get the prime number, you have to write the same prime number, and like this, 17 times 1 is 17. So your prime factors are 2 times 3 times 17. Understood how to divide it? Yeah. And I would like to show you another number that it is not difficult, but some of the students are confused in this type of prime factorization. So let's see how we can find its prime factors. 816, because its last digit is even, so we can divide it by 2. 2 times how much is 8? 2 times 4. Yeah. Okay, now here is 1. So most of the students are confused here. Here is 1, and 1 is smaller than 2, so it is not divisible by 1. Sorry, it is not 1 is not divisible by 2. So we have to take two numbers. As I already told you, if you are taking two numbers, you are allowed to take two numbers in the front at the first, but you are not allowed to take the two numbers at the after the first step. After this first number, you are not allowed to take these two numbers directly, but you can take these two numbers by adding 0. Understood? If you add here 0, then you are allowed to take these two numbers. So 2 times 8 is 16. Then again you can divide it 2 times, because this is the last digit is even, you can divide it by 2. It is divisible by 2. 2 times 2 is 4. This 2 times 0 is 0. Yeah, 2 into 0. 2 times 0 means 2 into 0 is 0. So you can write here 0. 2 times 0 is 0. 2 times 4 is 8. Again 2 times 1. 2 times how much? 0. 0. 2 times 2 is 4. Again 2 times 5 is 10, because here is this number is smaller than 2. We will take these two digits. So 2 times 5 is 10. 2 times 1 is 2. Again we can check it by 3. 5 plus 1 is 6, so it is divisible by 3. So 3 times 7. Yeah, 3 times 1 is 3, remainder 2, and 2 comes in front of here, comes in front of 1. So 3 times 7 is 21. Again this is prime number, so prime number is again divisible by the same prime number 1. So hence the prime factor of 816 are 2 times 2 times 2 times 2 times 3 times 17. So this much for today. We have discussed about prime factor, how to find the prime factors. We have found only the prime factors, not the other factors. There are the other different factors also, but